Welcome everybody to this year's European Trilinos user group meeting. I'm very happy that so many people have joined us. We have more than 60 people who registered for the meeting, which is actually, given the history of EuroTUG, an all-time record. So in the past, it usually has been around 30 participants. So for this year, I'm really excited that the numbers are that high. I guess that not all of them will join us today for this tutorial session, since today is specifically targeted for a tutorial for Trilinos beginners, and then some of the experienced users might probably join us then tomorrow and the day after tomorrow. So as I said, welcome everybody. My name is Matthias Mayr. I'm happy to have the pleasure to organize this year's meeting. As you can see from the picture, we planned and hoped to do this in person and in Munich. Unfortunately, this didn't work out due to the pandemic, but I'm happy that we came up with a virtual format that allows so many people to participate, and I hope that this will still be a fruitful exchange between all of us. I give a quick intro, and then I'll introduce some people who are important in this EuroTUG endeavor. So first, what's the European Trilinos user group meeting? It's a meeting series for Europe-based users and developers of the Trilinos project. It has a history, so there have been several meetings over the last 10-12 years at different places in Europe, and in this meeting series, this meeting series offers an opportunity to learn about recent developments in Trilinos. It allows users to report on their use cases and share their experiences, talk about their successes with Trilinos, but also get advice if there are some problems. It's a nice opportunity to interact with the Trilinos leadership and the Trilinos core developers. One of them who's already here, Mike Leroux. Hi, Mike. He's the overall head or the project lead of Trilinos. So I'm super excited that he took the time to help us in putting together a nice program, and also to join us in the meeting. And there will be several core developers from Sandia who will join us tomorrow and the day after tomorrow and share their updates on recent developments in Trilinos. And of course, since it's the focus is on the European Trilinos user group meeting, it's hopefully a nice forum to form a European network of Trilinos users and developers. At this point, I also want to acknowledge funding support and also organizational support by DTIC-BW, the Center for Digitalization and Technology Research of the Bundeswehr, and especially within the project HPC BW, a competence platform for high performance computing, who kind of provide a greater framework to organize and host and advertise this meeting. What's going to be ahead of us for the next day? So today, we're going to have a tutorial, Trilinos for beginners. So as I said in the beginning, it's really targeted for people who want to take a very first and very basic steps with Trilinos. And then tomorrow and the day after tomorrow, we will on each day have a set of user presentations where people who use Trilinos in their day-to-day research and in their application codes will showcase their use cases, how they use Trilinos, which results they obtain with it, and then we will also have a series of developer presentations where mostly people from Sandia National Laboratories will update us on the most recent developments within Trilinos. and also give us their like perspective on future developments and trends. For a detailed schedule, just have a look at the website. There you can find the most up-to-date schedule with exact times, speaker names, presentation titles. So far, there haven't been any changes to that schedule. If there should come up any changes, we'll immediately update the schedule. So just keep an eye on the website and on the schedule for all details. Now I'm happy to introduce some people. So first of all, Alexander Heinlein from TU Delft, who helped me to put together this meeting, where together we drew up the concept, put together the program, and hopefully designed a tutorial that's also useful for all of you. And Alexander's expertise in terms of Trilinos is that he's the main developer of the Frosh package. Let's call it package in Trilinos. Well, hi Alexander, thanks for joining us.
Yeah, hi everyone. We're also looking forward to this nice meeting of all the Trilinos people or users and developers in Europe.
Then I'll quickly want to introduce myself. My name is Matthias Mayr. I'm a postdoc and head of the Data and Computing Science Lab at the University of the Bundeswehr in Munich. And my background with Trilinos is also in linear solvers, where I'm an active developer of the MULO package used for algebraic multigrid methods. And then I want to particularly highlight two people from Sandia, Mike Roux and Siva Rajamanikam, who both helped us to put together the program, to acquire speakers, and really supported us in reviving the EuroTUG meeting series after the forced pause due to the pandemic. So Mike and Siva, thanks for helping us here. I think the community appreciates your support here very much.
Thank you very much.
So far, I think that's all I wanted to say about like about the organization of the meeting. There's one major announcement or one disclaimer that I need to make. So we're currently recording this meeting. The idea is that we actually record as many talks as possible, and then of course only if the speakers agree, and then we will try to upload the talks to some place on the internet, probably a Trilinos YouTube channel, so that you and also your colleagues who cannot join us today or within the next days can have a look at the content of this meeting. With that, I'll jump right into the, let's say, a little bit more technical part. And I want to give a quick introduction to Trilinos, what it's all about, especially for those of you who have never worked with it so far. Of course, the following slides will only give a brief overview over the software project Trilinos. These slides or this tutorial is really far from complete, since we in the limited time we only can cover a few aspects. But on the final slides of this presentation that we will also share with you, in the end we will provide some references to additional introductory material and tutorials, so that you can follow up with more detailed instructions later. So what is Trilinos? Trilinos is an open source library of software for scientific computing, and the here I took the liberty to just copy paste the mission statement from the Trilinos webpage. So the Trilinos project is an effort to facilitate the design, development, integration, and ongoing support of mathematical software libraries and enabling technologies within an object-oriented software framework for the solution of large-scale, complex, multi-physics engineering and scientific problems on new and emerging high-performance computing architectures. So there are lots of important terms in there. So first of all, what I personally want to highlight is it's really about design, development, integration, and ongoing support. And I mean, this is proven by the more than 20-year history of Trilinos that it's a long-standing and successful software project. That's not only about mathematical software libraries, but also about enabling technologies. And this especially, I think, is coined towards the idea of running Trilinos on various types of supercomputers with various types of hardware technology in the background, GPU accelerators, other accelerated devices, you name it. And it's not only about like mathematical research, and it's really about solving engineering and scientific problems at large scale at Sandia with Sandia internal applications codes, but also outside Sandia. And I mean, I know from the list of participants that many people, or I recognize a lot of names on the list of participants, and I know that some of them really work with application codes that heavily rely on Trilinos, and I hope that some of you don't rely on Trilinos yet might join us in using Trilinos in their day-to-day life. Life, or let's say work. If you want to do that, then Trilinos kind of has a layered based approach, and I'm open. I took this slide and this presentation from a Trilinos introduction given by Jen Velo, and it basically says, well, on the very top, of course, somewhere there's your application code, and your application code relies on several layers or capabilities that Trilinos provides. There's high level things, for example, discretization management, degree of freedom management, mesh management, things like that, finite element topologies, integration rules, quadrature rules, shape functions, all these things. Of course, what you also need are nonlinear solvers. So there's a variety of nonlinear solution methods available in Trilinos, and since many of them require you to solve linear systems in each iteration, there's an abundant work on linear solvers and especially preconditioners available in Trilinos. All of them, since we go for large-scale applications on parallel machines, really require you to store your data in a distributed fashion. So all these Trilinos packages at some level base on an implementation of a distributed linear algebra. There are two implementation stacks available in Trilinos, and we'll briefly touch upon them in a minute. And then at the very foundation, of course, there's the parallelization itself. It's either with MPI for this distributed memory, and then there's Cocos as an additional layer of parallelism. And I also mentioned here Cocos kernels, so a set of computational kernels written with the Cocos programming paradigm to really effectively leverage the full available parallelism on your machine. of course, MPI is not part of Trilinos. It's developed outside, and also Cocos officially is a standalone package. But when you get Trilinos, you automatically get a compatible clone or copy of Cocos with you. So there's no need for a Trilinos user to worry very much about how to install Cocos. So maybe a quick question: why should you use Trilinos? Trilinos provides a wide range of functionality, and if you look at the Trilinos website or at different resources, you see that Trilinos capabilities are organized in 5 product areas, and we will cover 3 of them within the EuroTUG meeting, namely the first 3. So the first one is it's called data services. This is all about, or this is the product area that covers distributed linear algebras or sparse matrices, vectors, graphs for matrices, and similar data containers, and also all kinds of operations that you can perform there. So matrix vector multiply, matrix multiply, vector norm computations, all these things that you know from your linear algebra classes, and what you can do with vectors and matrices. And this is all part of the data services product area. And we will have a presentation by Chris Seifert, who will give us an update on the recent developments in data services, either tomorrow or the day after tomorrow. Then there's an area, linear and eigen problem solvers. So as I mentioned earlier, there's this repeated task of solving very large linear systems of linear equations or eigenvalue problems. There's an entire product area devoted to that topic. And so, for example, Alexander's work with Frosch or my work with Mulu falls into that category, where we are working on preconditioners for linear systems. And then there's nonlinear solvers and nonlinear analysis tools. So this includes, let's say, basic nonlinear approaches like an implementation or various implementations of different variants of Newton's method, and also other nonlinear solution techniques for continuation methods and stuff like that, or also implementations of various time integration schemes. All these type of methods are covered by nonlinear solvers and analysis tools. And we'll also have a presentation there. Well, we'll have a presentation, an update on linear solvers, and we'll also have an update on parts of the nonlinear solvers toolbox, especially on an optimization package, RAL, and also on Saccado, a package for automatic differentiation. There is the product area of discretizations that covers the topics like finite element topology, basis functions, integral quadrature rules, degree of freedom management, all these things. Unfortunately, we couldn't get a speaker for that due to sheer scheduling reasons. And then Trilinos comes also with a framework team that for you as a user might not be, it's important that it's there because they take care of building and testing, making sure that Trilinos is well tested. But as a user, you usually do not interact that much with capabilities developed by the framework team itself. Once you start developing in Trilinos, then of course this changes, and you will contribute code and tests, and then this will become a bit more important for you. So the title of the slide here is, why should you use Trilinos? Well, Trilinos offers all these types of capabilities for you, and as I showed on one of the previous slides, you can build up an application code based on all these product areas with software that's all from one project and follows one philosophy. And I personally believe that this really helps to come up with a clean and sustainable and maintainable software design. Another reason or another aspect that of Trilinos that's probably useful and helpful for you is that Trilinos comes with performance portability for various parallel programming paradigms. And this basically means that Trilinos comes with MPI support and with an integrated COCOS support. So you can get distributed memory programming using MPI. You get performance on multi-core machines and also performance on different accelerator devices. And the nice aspect of performance portability, which is achieved through the COCOS programming model, is that you do not have to rewrite your code. You just reconfigure for a given hardware, and COCOS and the Trilinos implementation under the hood takes care of the details so that you can get performance really on any type of hardware, essentially for free, and especially without having to rewrite your code and migrate your implementation to CUDA or to HIP or to whatever programming model is required by the hardware that you want to use. I already gave a quick overview over the Trilinos product areas. Now let's dive a bit more into the details. So Trilinos internally is organized into software packages. It's a collection of currently 57 software packages. And each Trilinos package itself is a self-contained independent piece of software with its own set of requirements and its own development team. Of course, some of the packages depend on other packages to also group and build up on existing capabilities, but per se, they're self-contained. At the bottom, you just see a quick overview over the current state of the Trilinos packages directory. So you see, well, it's a bunch of them, and they have various names. For a detailed explanation on each of the packages, please have a look at the Trilinos website, and I'll reference the website in a minute. Let me talk a bit more about these Trilinos packages. So I mentioned earlier that there are, for the linear algebra, there are two implementation stacks. One is a purely MPI-based stack, which is based on the package ePetra, and then there's an MPI plus X stack, which is called based on the package tPetra. And then making this basic distinction between ePetra and tPetra based software, there are then a couple of packages that rely and build upon ePetra or tPetra and provide different capabilities. And I just quickly want to go through them. So let's say if you just want to solve with a direct solver, then there's Amesos if you're in the ePetra world, or Amesos 2 if you're in the tPetra world. If you want to switch to iterative solvers, Krylov methods, then there's Aztec 00, which provides Krylov solvers for ePetra based implementations. And then there's the Belos package, which provides Krylov methods for tPetra based implementations. Bellows can also deal with ePetra, but for simplicity, well, let's stick to this distinction here. Then for preconditioning for these iterative methods, there are also, there are one-level methods, for example, ifpack or ifpack2, if you're in the tPetra world, who provide one-level additive Schwartz methods, incomplete stuff like Jacobi or Gauss-Seidel relaxation, incomplete LU factorizations, Chebyshev polynomials, things like that. And then there are different multi-level approaches. On the one hand, multi-grid methods, where there's the ML package for ePetra and the MULU package for ePetra, and especially for tPetra implementations. And then besides multi-grid methods, there are multi-level domain decomposition methods available in the Shilu package, which is also capable of working with the more modern tPetra stack. For nonlinear solvers, you see that this is only listed in the ePetra side here. So some of the packages are only listed in one of the two columns, which means that they do not depend on the actual decision of ePetra or tPetra. They just can work with both. So the nonlinear solvers in Nox and Loca is one example. Another example is at the very bottom, like a utility package, Tefos, which is used for various things around parallel communication or memory management, reference counting pointers, things like that. There is, in terms of parallelism, we have on the one hand partitioning tools to distribute data to multiple parallel units. In the ePetra world, this is Sultan and Isoropia, and in the tPetra world, this is Sultan 2. And then for performance portability, I mentioned this earlier, this is Cocos and Cocos kernels, which is limited to the tPetra world. And then finally, something again spanning ePetra and tPetra is kind of an interoperability tool that allows to bundle multiple packages together and provide a nice interface to the user. And this can happen through Stratimicus and Thyra, and we'll have one or two more slides on that later today. For a detailed list of all these packages, please have a look at the Trilinos webpage, which is given here below, and which we will also see on the next slide. As I said, today we can only give a very high-level overview and only cover very few selected topics. But if you're interested in more resources on Trilinos, it's best to consult, on the one hand, the source code repository, which you can find on GitHub. And you see a screenshot here on the left. And then, of course, there's the Trilinos website here displayed on the right, which provides some general information, lists lots of points of contact, people that you can contact if you have specific questions about particular packages. There you also find a list of all packages and a description and details to all of these packages, and links to the Doxygen source code documentation for each of the packages. So if you really want to get started to work with one of the packages, this is for sure the place to go to find more detailed information.